Hello everyone. Welcome back to our series where we are discussing NCERT problems. Today we will look at NCERT problems from chapter 4. So let us look at problem 4.9. A cyclist starts from the center O of a circular park of radius 1 kilometer. So radius R is given to be 1 kilometer. Reaches edge P of the park. So starts from O, reaches edge P, and then cycles along the circumference and returns along QO as shown in the figure. So goes from O to P, then along the circular track, and then back to O, and then back to O. So this is the motion of the cyclist. If the round trip takes 10 minutes, so from O to P to Q and back to O, this time taken is 10 minutes, which is 1 by 6 hours, We have to find net displacement, average velocity and average speed of the cyclist. Now for net displacement, because initial position and final position are one and the same, net displacement is 0. Net displacement is 0. Now because net displacement is 0, rate of change of displacement would also be again 0. So velocity, average velocity is 0. Average velocity is 0. Now for average speed. Average speed is total path traveled. Average speed is total path traveled divided by total time taken. So total path traveled, what is the total path? OP plus PQ along the curve plus QO. That is the total path, and how much time has been taken? Time taken is T, which is 10 minutes. So OP is the radius, so it will be 1 kilometer. 1 kilometer plus PQ is 1/4 of the circumference of the circular park. So it will be 1 by 4 into 2 pi, radius is again 1 kilometer, plus QO is again a radius, so 1 kilometer, divided by time is 1 upon 6 hours. Time is 1 upon 6 hours. So we get 2 plus pi is, let us use 3.14 here. So we get 3.14 upon 2 divided by 1 by 6. Therefore we get 6 multiplied by 2 plus 1.57, which is 6 multiplied by 3.57. So upon simplifying, 6 sevens are 42, 4, 6 5s are 30 plus 4, 34, 6 3s are 18 plus 3, 21 kilometer per hour. Therefore, average speed of the cyclist is 21.42 kilometer per hour. So net displacement was 0 because initial and final positions were one and the same. Because there was no displacement, average velocity was 0, but average speed was not 0, because average speed is total path traveled divided by total time taken. Okay, so let us move to the next question. So question 4.10. On an open ground, a motorist follows a track that turns to his left by an angle of 60 degree after every 500 meter. So each side of this regular hexagon is 500 meter. Each side is 500 meter. Starting from a given turn, specify the displacement of the motorist at the third, sixth and eighth turn. So let us consider that just this turn has been taken by the motorist. Okay. Now let us mark the specific turns. So this will be the first turn. This will be the second turn. This will be the third turn. This will be the fourth turn. This will be the fifth turn, sixth turn, seventh turn, and eighth turn. Seventh turn and eighth turn. Okay. So we have to compare magnitude of displacement with total path length. So total path length would be the distance traveled. So we have to compare distance and displacement. Therefore, at third turn. So this is the third turn. So line directly joining this would be the displacement and total path traveled. So what we will do is first we will write total path traveled for each of the turn. Total path traveled for third turn, sixth turn and eighth. So 500, 500, 500. So till third turn 3 into 500. So 1500 meters was the total path traveled for 6 turns. 1, 2, 3, 4, 5, 6. So it will be 6 into 500. So it will be 3000 meters. And for 8th turn, 1, 2, 3, 4, 5, 6, 7, 8. So 8 into 500. So it will be 4000 meters. So these are all the paths traveled till third turn, sixth turn and eighth turn. Now let us look at the displacement. Let us look at the displacement. So for the third turn, displacement would be this line joining. Let's call it A, B, C, D, E and F. So displacement would be AD. Displacement would be AD, and we know diagonal of a regular hexagon is twice the length of its side. So this would be 2 into AB, which is 1000 meter. Okay. So this will be the displacement at the third turn. For the sixth turn, what is the displacement? Displacement would be 0 because the motorist has returned to his original position, which is point A. So for the sixth turn, displacement would be 0. Path traveled is 3000 meter. And for the eighth turn, displacement would be AC. For the eighth turn, displacement would be AC, which will be equal to, so this angle will be 30 degree. This angle will be 30 degree. So it will be 2 multiplied by AB cos 30 degree. So it will be 2 into 500 multiplied by cos of 30 degrees root 3 by 2. So it will be 500 root 3 meter. So it would be 500 root 3 meter. So for the third turn, path traveled is 1500 meter, but displacement is 1000 meter. For the sixth turn, path traveled is 3000 meter, but displacement is 0. And for the eighth turn, path traveled is 4000 meter, but displacement is 500 root 3 meter. Displacement is 500 root 3 meter. So let us move to the next question. So question 4.11. A passenger arriving in a new town wishes to go from the station to a hotel which is located 10 kilometers away on a straight road from station. So SH on straight road is 10 kilometers. A dishonest cabman takes him along a circuitous path 23 kilometers long and reaches the hotel in 28 minutes. So distance traveled is 23 kilometers. Time taken is 28 minutes. Time taken is 28 minutes. So first we have to calculate average speed of the taxi. Average speed. What is average speed? Total path traveled divided by total time taken. Total path traveled divided by total time taken divided by total time taken. So total path traveled is 23 kilometers and time is 28 minutes. Time is 28 minutes. So it is equal to 23 into 60 upon 28 kilometer per hour. So which is 7s are 15, 15 3s are 45, 4, 30, 4 upon 7. So it is 4s are 65, 9s are point 20, 2s are 20, 2s are 49.28 kilometer per hour. So that will be the average speed of the taxi. What about average velocity? Average velocity is displacement divided by time. It is displacement divided by time. So displacement would be the straight distance between hotel and the station, which is 10 kilometers divided by time taken is that only 28 minutes. 28 by 60 r. So this will be 10 into 60 upon 28. So there will be 150 divided by 7. So this will be 21.428 kilometer per hour, which after rounding off will be 21.43 kilometer per hour. So average speed would be 49.28 kilometer per hour. Average velocity would be 21.43 kilometer per hour. Now let us move to the next question. Question 4.12. Rain is falling vertically with a speed of 30 meter per second. So this speed is 30 meter per second. A woman rides a bicycle with a speed of 10 meter per second. 10 meter per second, and this direction is south. What is the direction in which she would hold her umbrella? So for her umbrella, the rain would feel that the net speed of rain, net velocity of rain would be 30 meter per second downwards and 10 meter per second towards north. So this will be the net velocity of the rain. This is 10 meter per second. This is 30 meter per second. Because for her, she would feel that the rain is coming at a slant because she has a velocity in this direction and rain is coming downwards. So for her, because she is moving, it would seem that the rain has net velocity at a slant. That rain has a net velocity at a slant. We have to find this angle theta at which she should hold her umbrella. So if we consider this triangle, this side is 10, this side is 30, this angle is theta. Therefore, tan of theta is 10 by 30, which is 1 by 3. Therefore, theta is tan inverse of 1 by 3. Theta is tan inverse of 1 by 3. Therefore, the woman riding the bicycle has to hold her umbrella at an angle of tan inverse of 1 by 3, which is approximately 18 degrees. Okay, approximately 18 degrees. So, to the vertical, she has to hold her umbrella at approximately 18 degrees so as to avoid getting wet due to the rain, because she has velocity 10 meter per second and the rain is falling at a speed of 30 meter per second. Question 4.13. A man can swim with a speed of 4 km per hour in still water. How long does he take to cross a river 1 kilometer wide? So this is 1 kilometer wide. If the river flows steadily at 3 km per hour and he makes his strokes normal to the river current. So this is the river current. He makes his strokes normal to the river current. So here his speed would be 4 km per hour normal to the river current. How far down the river does he go? So we have to also calculate how far down the river does he go. Because he is traveling normally, what he will do is his speed is 4 km per hour. So that would take 1 kilometer divided by 4 km per hour amount of time to cover the distance. Therefore, distance, how much he has to cover? Distance that needs to be covered is 1 kilometer. Time that he takes, we have to find. His velocity v is 4 km per hour because that is his speed with which he can swim. Therefore, time is equal to distance upon speed. So distance is 1 km, speed is 4 km per hour. So time is 0.25 hours. So in 1/4 hour, which is 15 minutes, he can cross the river, which is equivalent to 15 minutes. Now, how far down the river would he go? So while the person is traveling normally, what would happen? He is being pushed to the right because of the river flow. So because the river is flowing steadily, he will also be pushed off his straight path. So if the water was still, he would have just gone straight ahead. But because the river has a flow, he will move rightward. And what is the speed at which river is flowing? VR is 3 kilometer per hour. And for how much time is he in water? He is in water for 15 minutes. Therefore, distance is equal to speed multiplied by time. So speed is 3 kilometer per hour. Time is 1 by 4 hours. So this would become 0.75 kilometer. This would become 0.75 kilometer. Question 4.14. In harbor, wind is blowing at a speed of 72 kilometers per hour. At a speed of 72 kilometers per hour, and the flag on the mast of a boat anchored in the harbor flutters along northeast direction. Flutters along northeast direction. So wind is in the northeast direction. If the boat starts moving at speed of 51 km per hour to the north, so boat is moving to the north, so the flag will experience now wind from north towards south, which would be same as the speed of the boat. Okay, so that would be the wind experienced now by the flag. We have to find what is the direction of the flag on the mast of the boat. Okay, we have to find the direction, net new direction. So we have to add these two blue velocities. Now, initially velocity of the wind is, how much is it? 72 kilometer per hour. So let us find velocity of wind northward direction. It would be, because it is exact at northeast, this angle would be how much? 45 degree. So this would be VW upon root 2, because it would be cos of 45 degree. So it would be 72 upon root 2, which is root 2 multiplied by 36. So it is 36 multiplied by 1.414, which approximately comes out to be 51 kilometer per hour. So this approximately comes out to be 51 kilometer per hour. So velocity of the wind currently in the north direction is 51 kilometer per hour, and velocity of wind in east direction will also be equal to that. So this would also be approximately 51 kilometer per hour. Okay, now because this component is 51, because of the moving of boat, now the wind experienced, the extra wind experienced is towards the south, and its magnitude is also 51 kilometer per hour. So now after the boat has started moving, the net wind experienced would only be towards the east, will only be towards the east. So the flag will flutter towards the east, because original wind is northeast. The original wind's north component will be cancelled out by the movement of boat towards the north. So only the east component will remain. Therefore, flag will flutter towards the east. Therefore, flag will flutter towards the east. So hope you enjoyed this video. Hope your doubts were cleared. Let us meet in some time for the next problems of this chapter. Thank you.